Hi, my name is Anthony Rizzo, and I'm going to be giving my lab report on Lab 1 for Physics 2212. So the purpose of this lab was to prepare charged pieces of clear tape in order to determine how much excess charge is on one of the pieces. The goals would be to observe the interactions of the tape with other objects, and we would be using VPython to model the experiment and make our calculations. So a quick preview of the results of this lab include that the charged U tape had a positive charge, and the charge of the tape was 1.633 times 10 to the negative 8 coulombs. So some of the fundamental principles and formulas that we're going to be needing throughout this lab that I chose to include are the equation for calculating the electric force, calculating the gravitational force, which can also be looked at as using Newton's second law, that force is equal to mass times acceleration, where acceleration in this case is acceleration due to gravity. We have the equation for Coulomb's law in here, which we're going to need for calculating the charge. I chose to include the charge of an electron on there, which would need to be multiplied by -1 since electrons have a negative charge. And finally, I included the Coulomb constant, which in Coulomb's law can be seen as K. So some assumptions that we had to make for this lab are that air resistance is ignored, the tape was treated as a point charge where the charge is concentrated at the center, and each U-tape had about the same amount of charge, and that the charge is evenly distributed along the tape. We had to make these assumptions in order to get approximations for our calculations. So for the experiment, the system only includes the tape, whereas everything else is a part of the surroundings. For the procedure, we were to create two U-tapes by sticking one tape on top of another. The base tape would be stuck to the table and repeat. You rip the U-tape from the base tape and observe the interactions between the hanging U-tape and objects such as your hand. And we used a charged plastic pen. So some observations that I made was that the tape was attracted to both my hands and the plastic pen. This is because for the hands, charged objects are attracted to neutral ones. And for the pen was negatively charged when rubbed on clothing, so we were able to infer that the charge of the tape must be positive. Additional confirmation for the tape being positive is that when creating the U-tape strips, you're stripping electrons off of the tape after or when ripping it from the base tape. So for the main experiment procedure, you're then going to suspend one of the U-tapes, it can be seen as B here, between two surfaces, and you're going to get a second U-tape and progressively move it upward until the B tape begins to levitate, and you want to record this distance between the two. So some observations that I made include that the two U-tapes repel each other, obviously, when they are brought closer together. This is because they both have a positive charge, which is going to create a repelling force. It's important. I noted it's important to handle the U-tapes with caution because the tape will discharge with your body if it touches you. It's attracted to your hand because of the induced dipoles. And then here's my data that I collected on the length of the tape, the mass of the tape, and the distance between the two U-tapes. So now we're going to get into the calculations. So the first calculation that I made using Newton's second law is the force of gravity on tape B. So this is force is equal to mass times acceleration due to gravity. And there's a snippet of my VPython code on the right, which I used to calculate that. For the force of the electric field, this is going to be the force in the upwards direction, which is causing the levitation, and it's going to be equal in magnitude to the force of gravity, opposite sign. So next calculation is the charge on the U-tape. You can see that the equation I used there, which I also modeled in my VPython code to the right to calculate the charge, and to get the deficient or number, or in this case deficient number of electrons, you're just going to take that charge and divide it by E, which was 1.602 times 10 to the negative 19. So here I included my VPython coding model. The code is on the left, and the visual representation is going to be on the right. For my discussion, experimental error in this case came from a variety of factors. It could be inaccurate measurements of the tape, inaccurate distance between the suspended U-tape and the held U-tape, accidental discharge of the U-tape, and rounding error with calculations. So finally, for the what if questions, what if electrons had positive charge and protons had negative charge? What would change about the observations? So essentially nothing would change here except for the charge of the tape becoming negative. The U-tapes will still have the repelling force on one another. And why is it important to handle the charged tapes as little as possible? This is because, as I mentioned earlier, touching the charged U tape will create a transfer of charge to your skin, therefore decreasing the positive charge, and that would just make the experimental results more difficult to see. Thank you.